The universe remains a mystery. Today we understand so little of it. It's constituted of visible matter, dark energy, and dark matter. Whatever we see around us, on Earth, in the solar system, in galaxies, stars far away, I'm told constitutes only about 4 to 5%. Rest of it remains unknown. We are part of the visible universe. I have with me Prof Priyamvada Natarajan. She is a specialist on dark energy, dark matter, black holes. She works at the Yale University in the United States of America. Thanks a lot for speaking to me, Professor Natarajan.
Thanks for inviting me.
Professor Natarajan recently discovered a new way black holes could be made. There's a lot to talk about, and let's get to the invisible part of the universe. How come so little is visible?
It's an embarrassment, actually, that we know only about such a small portion of the universe, a mere 4%, that's made of ordinary matter that emits light. You know, everything in the periodic table, including everything that we're made of, that's just 4%. And 96% is completely unknown. So that's dark matter, which is about 26%, and dark energy, which is 70% of the inventory. The thing that we do know about dark matter, these sort of elusive, invisible entities, is what they do in the universe. So we know what dark matter does and how it manifests. We also know what dark energy does. So we know that the universe is expanding. And recently, in 1998, it was discovered that the universe is not just expanding, but that the expansion is accelerating. And we believe that it's dark energy that is causing the universe's accelerating expansion. And with dark matter, we know it exists and that every galaxy in the universe has some dark matter in it, and there's dark matter smeared lightly everywhere in the universe. We know it was likely a particle. We think it's matter, so it's a particle that was probably created in the very early universe. But we don't know which particle. We don't know any other properties of the particle. But we're looking. It's not for want of looking. So for 30, 40 years, many, many different kinds of experiments around the world have been trying to look and search for this dark matter.
Why does it remain so elusive?
Dark matter, it turns out, the particles, the specific particles they are likely made of, do not interact with light. So therefore, we do not get any signals. You know, light is a cosmic messenger. Everything we see and know about the universe comes from visible phenomena. So the entities, dark matter, dark energy, and even black holes, they don't really participate directly in interacting with light. And that's why they've remained so elusive.
How soon can we figure out what dark matter, dark energy is? You're a specialist on that.
You know, I'm not a betting person, but I'm hoping it will be within my lifetime. So that's all I'd be willing to say. But I think the discoveries are imminent because the effort has been international effort. And I know that India is in on it. So we have 2 detectors, one underground detector in Jharkhand and another telescope at Hanle.
The gamma ray telescope.
Gamma ray telescope at Hanle in Ladakh, which is looking for very, very special signatures if dark matter actually has some additional properties that it well may, we don't know, then you would get a shower of very energetic particles and you would get some interactions that would be detectable in the gamma rays. So that, you know, this is a bet that we are making on what exactly dark matter might be. For a very long time, we assumed a certain set of properties. And as I said, for 30, 40 years, we've been looking, we haven't found it. So we've now moved a little bit to start exploring slightly different part of the allowed possibilities. So particle physics actually circumscribes the available possibilities for the kinds of particles that you could have that are produced in the early universe. So let's see. Now we've opened these new doors. Maybe we'll find it now.
You're also a specialist on black holes. You also discovered a new way black holes are made. Tell me what black holes are and what was your specific discovery?
So black holes are these enigmatic objects in the universe. They really are a place in the universe where the gravity is so intense that not even light can escape. So obviously any matter that gets close to a black hole will get completely swallowed by the black hole. In fact, even light doesn't make its way out. So it was believed that black holes are really made from the end states of stars. So very massive stars that are about maybe 10 times more massive than our own sun, they live their life out and then they explode when they've exhausted all their nuclear fuel and they leave behind a little black hole. We have started finding very, very massive black holes very early in the universe. So we were starting to find black holes that were 1 billion times the mass of the sun, in place in the center of galaxies, actively gobbling matter. So that's what we see about a black hole. We don't see the black hole itself, but we see the matter that is being pulled in by the gravity of the black hole. So at some level, we are seeing the dying gasps of matter. And that glows in the X-rays typically. So that's how you see black holes. And so we were starting to find these black holes that were 1 billion times the mass of the sun when the universe was very, very young. So then it's a big challenge to start from a tiny black hole that's the end state, a stellar corpse, and to make a black hole that big. So about 20 years ago, I started working on a theory, a new kind of physics of how to make the black holes to be much more massive from when they're born, to bypass the formation of a little star and actually see if the physics would allow us to bring a lot of gas into a very compact region and make a black hole that starts its life out as 10,000 times the mass of the sun, maybe even 100,000 times the mass of the sun, so that it doesn't have to grow too much to become a quasar that we see glowing in the universe. So it turns out, it took about 15, 20 years for the computers to get fast enough to actually simulate this process. And we had worked out the physics very early on, but we need to see if it can happen in our universe. And do we have the conditions? Do we have the places in our universe? And, we know a lot of the properties of the universe. And so it turns out there are regions of the universe where this can happen feasibly. And, we believe that these are rare, so it would be quite a challenge to find it. But in 2017, we wrote a paper when JWST, James Webb Space Telescope, was not yet launched, but it was very much going to be launched in a few years. And we put out a set of predictions where we showed that, James Webb Space Telescope, with the window of the universe, with the eyes with which it sees the universe, should be able to detect such objects because they would be very, very distant. And that such an object, such a black hole, if it did exist and formed in this particular way, would also glow in the X-ray. So we should be able to simultaneously see it with the Chandra X-ray telescope and James Webb. So we were really lucky. There was a gift from the universe last year, and there is this object UHZ1 that actually satisfies all the properties of these direct collapse black holes that we predicted way back when. And I think it's been really, really exciting. It is such a rare object that, I just cannot but help say that we've been super, super lucky. It's really a miracle that we detected this.
One type of black hole you predicted, it was discovered. If credit goes to you. The earlier black holes, there was also an Indian connection. Tell me a little bit.
Yeah, we have the Indian mafia on black holes. So, it was Subramaniam Chandrasekhar who actually made that radical proposal and theoretical prediction that the end states of massive stars would leave behind a stellar corpse and a black hole. And yeah, it's a real privilege to have kind of inadvertently followed in his footsteps in many ways, depending on where I studied as well, and to have also worked on in an area and to show that, to augment what he did and show there's another way as well.
Have you ever thought of visiting a black hole?
Oh gosh, it's just too dangerous. I know how dangerous it is. I wouldn't want to go anywhere near a black hole. I would just want to stay afar and watch watch light and the tactics of light around, the bending of light around a black hole rather than get close. Partly because it's vanity. You know, when you start falling into a black hole, suppose I went in head first, right? The difference in the intensity of gravity between my head and my feet falling in would be so strong that I would be pulled out and made into a little spaghetti and I would lose my hair. So, I love my hair. So I am not going to go anywhere near a black hole. I think I'll be an armchair watcher of black holes.
Maybe there's a better universe on the other side of the black hole. Much better than what we are standing in.
That's a good point. I actually do believe, and the operative word is believe because we have no evidence. I actually believe in the multiverse. I think there's an infinite number of universes out there. Yeah, sure. But I think for now, I like this universe.
Now, India also has experiments to understand dark matter and dark energy. We have the space-based satellite. We have stuff which is sitting underground. Tell me a little bit more about what you know of these.
So there are two very interesting and exciting experiments in the search for dark matter that India is playing a very important and significant role. One of them is an underground mine, an old uranium mine, and in Jharkhand.
The Jadugodam
and
matter laboratory.
Yeah, and the other is the gamma ray telescope in Hanle,
In Ladakh.
Yeah, and so both of these experiments are engaged in trying to see if there are any additional signals we could get from dark matter, from the particle interactions. So one of the things that we do know is that dark matter is likely some particle that formed in the very early universe. We don't know. There's a lot of uncertainty about the full set of attributes and properties of these particles. We assumed a certain simplistic set of properties and we've been looking for them. Because we've come up empty for the last 3-4 decades, now it's time to start opening up our search, becoming more open to other sets of particles. So these two experiments represent an opening up of additional signals that we think we can get from dark matter if there is some level of self-interactions, if they interact with each other. We know they don't interact with light, but perhaps they interact with each other a little bit. If they do, we are likely to see these gamma rays. And that's really going to be exciting if that happens and if we are able to detect that.
Yeah, I'm told the gamma ray telescope called MACE is the highest altitude gamma ray telescope in the world. Next is only in space.
Yes.
So you'll get results which are gathered in the space-based observatory and in the land-based observatory. Is that a fair understanding?
Absolutely. And it's very, very exciting because beyond the dark matter question, these gamma ray telescopes are also super important for black holes. So black holes do not always just start sucking in matter. They occasionally, not all the matter that goes towards a black hole actually makes it in. Some of it dribbles. Black holes are poor eaters. So they dribble out. And they come out, and especially if the black hole is spinning as well, they come out as energetic jets of energy and matter that are pushed out from a black hole. They have a lot of gamma rays. And this phenomenon can actually be detected by this telescope at Hanle. And so what we can do is the combination of ground and space data can give us a fuller picture of this phenomenology, which is really quite rich.
The other place where cosmologists, astrophysicists are working hard is on gravitation waves. We had the discovery of gravitation waves. India is also now part of the global LIGO experiment. Tell me a little bit about gravitation waves and how will it help understand the properties of the universe and how will India leg help?
So gravitational waves are basically tremors in space-time that result when two black holes actually merge, collide with each other and merge. When they do, they set off these gravitational waves that would travel towards us. And the LIGO collaboration, LIGO, Virgo, and now India are part of this collaboration that has been detecting gravitational waves from merging stars nearby in and around our own galaxy. So the problem has been localizing where these events are happening. The more stations, the more nodes we have on the Earth, so LIGO, Virgo, Kagra, and India, is going to be able to help us pinpoint where those two black holes merged, which is the origin point of the gravitational waves that are now detected. So India, the detectors in India, LIGO India, is going to play a very important role in helping make these measurements more precise and therefore extract much more physics and deeper understanding of physics. I think it's a time of great renaissance for India. We are in on all the big mysteries in the universe, and we are active participants. And I think that because in science, all these extraordinary phenomena, right, these extraordinary discoveries, they are actually validated when there are many independent measurements, independent lines of evidence. So it's very critical for us to be on board with these new sets of experiments at the frontier of cosmology today.
As an astrophysicist who's trying to understand the mysteries of the universe, one thing remains a mystery is the neutrinos.
Yes.
They're passing through us even now in billions of particles. Do you regret that India was never able to get the India-based neutrino observatory off the ground?
Well, I think neutrinos are elusive, and of course, thankfully for us, right, they do traverse through our bodies and they don't actually impact us, and thank God for that. But there are many, I don't think it's a lost opportunity, because there are many other laboratories around the world that have, characterized and studied the properties of neutrinos. So there are, of course, open questions. But I think given that, we are really at the forefront of the invisible universe with the dark matter and LIGO, I think we're doing pretty well.
What more do you think India should do which can help in deciphering the mystery of dark energy, dark matter, other than just having MACE, the underground laboratory at Jadugoda, and the XPOSat, the satellite space-based observatory which India recently launched? What else can we do?
So I think we are leveraged very well, intellectually speaking, in terms of the balance of ground-based facilities and space-based facilities. I think the next steps that India could take is, of course, have everything running and calibrated and running as soon as possible, but also perhaps join in on more sort of international collaborations, because we have a wonderful, talented STEM workforce, and it would be great if India was much more actively participating in these large surveys that are done now. So the Dark Energy Survey, for example, and the Sloan Digital Sky Survey and its various incarnations. So I think the next step would be to start getting involved more and more with large collaborations, because now is the era of big science. And I think we can get in on all the exciting discoveries if we are leveraged across the board, across the electromagnetic spectrum, and on experiments of very different scales. Starting from CERN. So India's had a very strong presence in CERN for a very long time. So astrophysics is also going in that same direction of becoming big science. But I think we have a really nice portfolio of science. There's nothing stopping us now from making these discoveries. I don't see why India would not be a key player in future science.
You were born in Coimbatore. You trained at the MIT, Massachusetts Institute of Technology. Then you went on to UK to do your PhD. You interact a lot with Indian science students and young faculty. Any message for them?
I think that the young students in India, incredibly talented. They're super curious. I would just encourage any of them who have interest in doing basic science to follow through. It's a tough path. The training is tough and it takes a lot of dedication, but I think they have it. They have the talent, and I think it would be a shame if not a lot of the people who actually want to go into science don't have the opportunities. I think now we have the opportunities as well for doing cutting edge research in India. And for the young faculty, I would just say that, just exploit this wonderful talent that you have in your students. I think it's very, very hard. The challenge that we have in the United States and in many other countries is actually recruiting STEM students. And here the talent pool is really endless. So I think there are huge advantages that you have working in India.
One institution which attracts a lot of good talent in India is the Indian Space Research Organization. I call it the island of excellence in a sea of mediocrity, which India is. They've had a series of successes recently. How many of them came and registered for you?
Oh, every one of them registered for me because I've been an ISRO fan since I was a child growing up in India. In fact, the college essay I wrote to get into MIT was about witnessing a satellite launch from Sriharikota. So it goes back a long way. The love affair with ISRO goes back a long way for me.
Did you finally get to Sriharikota?
Yes, I did.
What did you watch there?
So I launched one of the SLVs.
Oh, lovely.
Yeah.
So you've seen Sriharikota Island and the... Now, we had a string of successes recently, Chandrayaan-3 being a spectacular example. How did it feel to you?
I mean, an enormous amount of thrill. I mean, I really think that ISRO and the technical expertise they have is unmatched in the world. Also in terms of the leanness, the economy with which, in terms of budgets that they work with, and the excellence of the instrumentation and how well they work. So I think, ISRO is really a jewel in the crown. And, Chandrayaan, every mission that ISRO starts is path-breaking in its own way. And I think that remains such a matter of pride, and it's so exciting that they're breaking new ground. They're not just repeating what others have done before. They're going farther and doing it better and doing it with a lot less time as well. I think they're also super efficient in planning and executing their missions.
Aditya L1, the space-based solar observatory, do you think it will help better understand our star?
Yeah, I mean, you would think that it's only the distant universe that has these unsolved mysteries. There's a lot we don't know about our own parent star. And I think with the combination of the Parker probe and Aditya, we're going to know a lot more about the sun. And, for me, all of these, moments, it's like deja vu moments because I got my start in research working on a project on sunspots, research project with Dr. Nirupama Raghavan, the late Dr. Nirupama Raghavan, at Nehru Planetarium in Delhi when I was in high school. So, I sort of find that all my childhood passions are sort of, coming of age now, especially with India's involvement in these space and ground-based missions.
Are you involved in any way in consulting with ISRO or helping the astrophysics community in India?
No, I'm very much involved scientifically with the astrophysics community. I collaborate with a lot of people, and I'm engaged with many institutions. I would love to be involved with ISRO. I am not at the moment.
Maybe, who knows?
Yeah,
Very soon you would be able to, when they launch another observatory or they come out with better findings on XPOSat. It's a marvelous satellite which has been put forward. The big question, dark matter, dark energy, when do we touch and feel and get to know it?
I don't know. Hopefully in my lifetime is all I can say. The course of science is so hard to predict, right? The discovery could be right around the corner, and we may not be aware of it, and it may just sneak up on us. So I'm hoping that something like that happens, and there's a surprise from the universe again.
So nice to speak to you. What a pleasure understanding the invisible things about the universe. May you find dark energy, dark matter, and make India proud. Thanks a lot.
Thank you so much for having me. Yeah.
So that was Prof Priyamvada Natarajan, the astrophysicist, somebody who specializes in understanding or first searching for dark energy and dark matter. If 96% of the universe is unknown, one can only imagine what the future lies for us. Lucky we are visible. Professor Natarajan looks at stuff which is invisible. Mysteries of the universe continue to baffle us. In New Delhi, Pallava, Bagla for NDTV.